Assalamualaikum and hi everyone. We are still on the discussion of the stability analysis using Root-Hurwitz criterion method. So while we employ this method, sometime we will see the special case that we have to take into account. There are two cases that can occur when we employ this Root-Hurwitz. The first case is the root table sometimes will have a zero only in the first column of a row. And the second special case is the the root table sometimes will have an entire row that consists of zeros. So let us look at one by one. So for example, for this example, for the case number one, so we can see this example 5.4. So for example, determine the stability of the closed loop transfer function with ds equal to 10 divided by s power of 5 plus 2s power of 4 plus 3s power of 3 plus 6s power of 2 plus 5s plus 3. So this is the closed loop transfer function. So based on this closed loop transfer function, we can take this denominator part and then put this one equal to 0 like this. So this one we can consider as a characteristic equation for the system. Okay, from this characteristic equation, we can analyze either the system is stable or not. So we can do that by employ this RH table. So how to complete this RH table is same like what we have discussed before. So first we just fill in the first row and the second row with the coefficient from this characteristic equation. Okay, this first row is depend on the odd coefficient of this characteristic equation, and the second row is depend on the even coefficient of this characteristic equation. Okay, after that we just employ formula that we have discussed to obtain this coefficient and the other coefficient. So for this case, when we apply that formula, where the formula is this coefficient time with this coefficient minus this coefficient time with this coefficient, and all this we divide by this coefficient. So when we do that, so this one times this one becomes 6, minus this one times this one also 6. So that means the numerator becomes 0. So that 0 we just divide by 2 here. Uh, so when 0 divide by any value, so we get the result become 0. So when we get this one is 0, so we have a problem to complete this RH table. So how to overcome that problem? So we just represent this 0 with any symbol. So in this case, I use epsilon to represent this 0. So when we put this one is epsilon, so we can continue to complete this RH table by employ the same formula where this coefficient time with this coefficient divide by and minus this coefficient time with this coefficient divide by this coefficient. So we get this coefficient, and then the rest we can get the coefficient by using the same procedure. Okay, so after we have complete this RH table, so now we can check either the system is stable or not. So how we can check? So based on this, so we try to put this epsilon positive value and negative value. For example, we put positive value here. So when we put positive here, so that means there is no changes from here to here, and because this one is positive and this one is also positive. Okay, when we put this one is positive, so this one become 6 minus 7 divided by positive. So that means negative divided by positive become negative. So that means there is one changes occurs from here to here. This one is positive and this one is negative. So one changes. Okay, for this one, when we put this epsilon is positive, so this one become 42 minus 49 is negative 7 minus 6 is negative 13 divided by this one 12 minus 14 equal to minus 2. So minus divided by minus become positive. So from here to here, so we have another sign changes because this one is negative, this one is positive. Okay, from here to here, there is no sign changes because this one is positive, this one is also positive. Okay, now let us change this sign with negative. Okay? So when we put this one is negative automatic. From here to here, we have one sign changes. Okay, so let us put in this equation. When this one is negative, so this one is become negative 6 minus 7. So this is negative 13 divided by negative, because we just put this one is also negative. So negative divided by negative is positive. So that means from here to here, we have another changes because this one is negative, this one is positive. Okay, next, uh, we put that negative sign with for this equation. So this one become negative 42 minus 49. So means that equal to negative 90, sorry, negative 87. Okay, negative 87, sorry, negative 97, 97, sorry, 91, negative 91 minus, because this one is negative square, so become positive, so minus 6. Okay, so this part become negative, and also when we put this one is negative, this part is also negative. So negative divided by negative is positive. So from here to here, there is no sign changes because this is positive, this one is also positive. From here to here is also, there is no sign changes because this one is also positive sign. So that means for that case, when we put this epsilon is negative, so we have two sign changes from here to here and from here to here. So from there, confirm that for this system, we have two poles that are located on the uh, right half plane. Okay, there are two poles that are located on the right half plane. So the system is unstable and has, and because we have uh, pole on the right half plane. Now let us look at another case. So for this case, for example, we have the system with ts equal to 10 divided by s power of 5 plus 7 s power of 4 plus 6 s power of 3 plus 42 s power of 2 plus 8 s plus 56. So based on this closed loop transfer function, so we just take this part, this denominator part equal to 0 to represent the characteristic equation for the system. So based on this characteristic equation of the system, we can, based on this characteristic equation, we can fill these two row, these two first row with the odd and even coefficient of this characteristic equation. And then after that, we just apply the formula to get the other coefficient for this to complete this RH table. So when we apply that formula, so we get this value is equal to 0, 0, 0. So that means entire row is equal to 0. So this is different with if we compare to the previous example. So the previous example, only this first column equal to 0. So but for this example, all this entire row is equal to 0. So when we see this problem, so we have to do something so that we can complete this RH table. So what we can do is we just to use auxiliary polynomial equation to to replace this value of 0 in this row. Okay, so how we can get the auxiliary equation? So the auxiliary equation we can get from the row before. Okay, so in this case, the row before is the row at the at the order at this order, which is equal to 7, 42, and 56. Same like before, we where we can simplify this one by divide all with 7. So because when we all divide all with 7, this one become 1, 6, and 8. And also you can just use 7, 42, and 56. So the result, you can get the same result. Eh? Okay. So in this case, we use the simplify value, which is 1, 6, and 8. So this one is represent 1 as power of 4. This 6 is represent as power of 2. And this 8 is represent 8, 8 power of as power of 0. So from here, the polynomial equation that we can use use in this case is PS equal to S power of 4 plus 6 S power of 2 plus 8. Okay. So in order to fill this form, this row, so we have to differentiate this auxiliary polynomial equation. So by using differentiate this equation, so we get 4s power of 3 plus 12s plus 0. And then we just put this value in this row. So 4, we just put here 4. 12, we just use here, put here 12. And 0, we just put here 0. Okay, same has this row. So because we can divide all this with 4, so we just divide all this with 4. So this one become 1 and this one become 3. And this one, when we divide by 4, also same 0. So, and after we get this value, so we can continue to complete this RH table. Okay, that is two uh, special case that we have to take into account while we use this RH criterion method. Thank you.